So now we produce a total complex from two given chain complexes. So say we are given a chain complex like this, denote this by P. So going from P4 to P3 to P2 to P1, and your differential is delta. And you are given another chain complex, say Q, going from Q4 to Q3, Q2, and so on, and the differential or the boundary map given to you is D. So given these two complexes, we will construct a total complex and we will use tensor product. So now focus on this complex first. So you take this complex and put it in the column like this, in the 0th column. So for the 0th column, you have taken this entire complex, put it like this, and then you tensor each term with P0 because this lies in the 0th column. Now again, you put this complex vertically like this in column 1, Q4, Q3, Q2, Q1, Q0, and then you tensor it with P1. So the differential here is D, and from P0 to P0 is just the identity map because P0 is just getting carried to P0, so you have identity map. Here again P0 is getting carried to P0, just identity map, and Q2 gets carried to Q1 via our this map D. So nothing much has been done. Here we put a negative sign here in front because we need this anti-commutative condition, and we said that in the odd column we put a negative sign. So this is column 0, so you have 1 here. This is column 1, so you're tensoring with P1, you put a negative sign. Now again you put this vertically in column 2, so tensor with P2 everywhere. So again you will just have D, the boundary map taking Q3 to Q2, and so on, just exactly like this. And identity takes P2 to P2, identity takes P2 to P2, and so on. You construct this in the 3rd column also, put this in the 3rd column. Now tensor with P3. Again our maps would be -1 tensor with D, -1 because we are working in column 3, you're tensoring with P3. So again this will be -1 tensor D. So same thing with column 4, you tensor with P4. You have the same chain map like this, but now since you're working in column 4, so you just have 1 tensor D. So now we don't do anything much, we just put horizontal maps. So if you put horizontal maps like this, you can go from P4 to P3. You're taking Q4 as a constant, so you're just going to do delta tensor with 1 because this second parameter here, this is not changing, and here you just put delta, and so on. So now you can construct this map delta here. So this will give you a total complex. So let us see this. So now these green arrows represent this delta right here. So it is going from P4 to P3 to P2 to P1 to P0. So you can say P4 to P3 to P2 to P1 to P0, P4 to P3 to P2 to P1 to P0. So this nothing much has been done, and you just the same delta which acts on P1 to P0, this delta acts from P2 to P1, and this delta acts from P3 to P2. Again you have delta tensor 1 here, and 1 does nothing because everything here is Q1. So Q1 carries to Q1, 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 Q1. Here again this 1 does nothing, it just carries Q2 to Q2, and delta acts on P3 to carry it to P2. So this is how you can construct a double complex. So again this is our grading 0 term. Grading 1 term again is the anti-diagonal, so this is grading 1 term, then this is grading 2 term, and then you have grading 3 term, and so on, because the indices here sum up to 2, 0 plus 2, 1 plus 1, 2 plus 0. This is the first term because the indices sum up to 1. This is 0th term, and so on. So we have been able to construct a total complex from just 2 given chain maps.